Recent Atlantic Ocean warming is unprecedented in nearly 3,000 years. University of Massachusetts Amherst reports on phys.org. But we're also going to take a look at Null School to see the air temperatures and water temperatures of the North Atlantic. We also see the North Pacific, which is even warmer in the north than it is anywhere in the equator. Equatorial waters are colder than North Atlantic and North Pacific. So what is going on there? We have something similar in the area around Antarctica too. We'll take a look at that in a few seconds. Taking advantage of unique properties of sediments from the bottom of Sawtooth Lake in the Canadian High Arctic, climate scientists have extended the record of Atlantic sea surface temperatures from about 100 to 2,900 years, and it shows that the warmest interval over this period has been the past 10 years. That's terrible. Now, the team led by Francois Lapointe and Raymond Bradley in the Climate System Research Center of University of Massachusetts Amherst and Pierre Francus at University of Quebec, INRS, analyzed perfectly preserved annual layers of sediment that accumulated in the lake on northern Ellesmere Island, Nunavut, which contained titanium left over from centuries of rock weathering. By measuring the titanium concentration in the different layers, scientists can estimate the relevant temperature and atmospheric pressure over time. The newly extended record shows that the coldest temperatures were found to be between 1400 and 1600 AD, and the warmest interval occurred during just the past decade, the authors reported. Francus says, our unique data set constitutes the first reconstruction of Atlantic sea surface temperatures spanning the last 3,000 years, and this will allow climatologists to better understand the mechanisms behind long-term changes in the behavior of the Atlantic Ocean. When temperatures are cool over the North Atlantic, a relatively low atmospheric pressure pattern is found over much of the Canadian High Arctic and Greenland. This is associated with slower snow melt in that region and higher titanium levels in the sediments. The opposite is true when the ocean is warm. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. The opposite is true when the ocean is warmer. Atmospheric pressure is higher, snow melt is rapid, and the concentration of titanium decreases. Lapointe says, using these strong links, it was possible to reconstruct how Atlantic sea surface temperatures have varied over the past 2,900 years, making it the longest record that is currently available. And details appeared in Proceedings of the National Academy of Science. The researchers report that their newly reconstructed record is significantly correlated with several other independent sediment records from the Atlantic Ocean, ranging from north of Iceland to offshore Venezuela, confirming its reliability as a proxy for the long-term variability of ocean temperatures across a broad swath of the Atlantic. The record is also similar to European temperatures over the past 2,000 years, they point out. Fluctuations in sea surface temperatures, known as the Atlantic Multi-Decadal Oscillation, or AMO for short, are also linked to other major climate upheavals, such as droughts in North America and the severity of hurricanes. However, because measurements of sea surface temperatures only go back a century or so, the exact length and variability of AMO cycle has been poorly understood. Climate warming in the Arctic is now 2 or 3 times faster than the rest of the planet because of greenhouse gas emissions from burning fossil fuels. Warming can be amplified or dampened by natural climate variability, such as changes in the surface temperature of the North Atlantic, which appear to vary over cycles of about 60 to 80 years. Lapointe, who has carried out extensive fieldwork in the Canadian Arctic over the past decade, notes that it has been common in recent summers for atmospheric high-pressure systems clear sky conditions to prevail over the region. Maximum temperatures often reach 20 degrees Celsius, 68 degrees Fahrenheit, for many successive days or even weeks, as in 2019, which is very hot for that area, of course. This has had irreversible impacts on snow cover, glaciers and ice caps, and permafrost. Bradley adds that the surface waters of the Atlantic have been consistently warm since about 1995. We don't know if conditions will shift towards a cooler phase anytime soon, which would give some relief to the accelerated Arctic warming. But if the Atlantic warming continues, atmospheric conditions favoring more severe melting of Canadian Arctic ice caps and the Greenland ice sheet can be expected in the coming decades. Now, we did a few days ago a video on the Greenland ice sheet. We found that on the eastern area, especially that is not far from Iceland, there are volcanoes under there. And that is, of course, heating the ice sheet, causing it to melt. Greenland. Now, in 2019, Greenland ice sheet lost more than 500 billion tons of mass, a record, and this was associated with unprecedented, persistent high-pressure atmospheric conditions. Lapointe notes, conditions like this are currently not properly captured by global climate models, underestimating the potential impacts of future warming in Arctic regions. Let's take a look at Null School to find out what the temperatures are like now in the Arctic. And this is, as we know, is our Arctic area. What are we showing here? Let's see. Right here we're showing the chemicals, the SO2, sodium dioxide, and let's go to CO, carbon monoxide, a lot over eastern area around New York. And let's see, what's this, a lot around here, Africa. China, of course, and India, the world's polluters. And let's go to the temperatures now. Shall we go to air temperature? Air temperatures, that's the wind. Let's go to temperatures. Okay, air temperatures. Okay, so we're pretty, look at this warmth here. Look at that, isn't that something? The warmth here, look at this. Look at this. Over Scandinavia. This is the air. Let's go over, okay. Over here is very cold over Greenland. Let's go back over Canada. But this is what I'm really, look at this. Very warm here. And this, of course, is the Aleutian Islands of Alaska. Look at this. That's Pacific. Let's go to the Atlantic. Over Scandinavia, especially all the way up here. Svalbard. Look at this. Let's go back. Okay. Look at this. It's green up here as well. Okay, let's go to the water now. We can go to the ocean temperatures. Warm. It's warmer up here than it is in the mid-Atlantic. Warm. Iceland, Greenland, Svalbard. And of course, this is the Pacific as well. Okay. The Aleutian Islands, Japan. Look at the warmth here. Warmth. I don't know what's under there. Could it be undersea volcanoes? We don't know. And that's the path to the mantle plume of Hawaii. But look at this. It's not only, here we see it's not only the ocean temperatures of the Atlantic, the North Atlantic. We also have it especially warmer temperatures in the Pacific. Look at this. These are warmer than they are in the equator, the equatorial zone. Let's go to, we see some here as well. Look at this thing. That's water temperature. That's the air temperature there. Water temperature, ocean. That's amazing. That is amazing. Here as well. That's I was going to say crazy, but look at this. It's hotter in the Pacific than it is in the North Pacific than it is in the North Atlantic. Something is going on here. Could it be volcanism? We don't have... Now, Japan, okay, look, it could be the Fukushima radiation, but what is that in these three areas? Anyway, if you have any ideas, please let me know. I'll leave links below for you for this. And again, Happy New Year, health and happiness and prosperity, God's blessings on all of you. Thank you for your support.